Hey guys, in this video we're going to talk about the master theorem and hopefully how it will make your life easier. So remember the last example that we went over? So in the last video we came up with this recurrence for one of our power functions, and then, we solved, and it was all that math over like 2 or 3 pages, right? So what if I told you that you could solve this in just seconds? I feel like Morpheus. Okay, so you can. So with the master theorem, if you have something in this form, and that's the important part, it has to be in this form. You can't do it with all recurrences. It has to be in the form of t of n divided by some b plus c to the n of some k. So some function. This needs to be some function, which it can be a number, it can be, just a constant. And then this a can be 1, of course, but it can also have something in front of it as well. Okay? It has to be in this form. But if you do have it in this form, you get this. So if you compare a and it's less than b to the k, then your function is going to be in big theta of n to the k. So it's not exactly the same thing that we did. We didn't find the exact number of operations like we did before. However, really the only reason that we find the exact number of operations is so that we can figure out what the big theta is, or what the big omega, or big O is. Okay? So this is the first one. So if A is equal to B to the K, then you have T of n that's in big theta of n to the K log n. And if A is greater than B to the K, then you have that it's in big theta of n to the log base B of A. I tried to nicely color code this. So let's do that example. So our A is going to be 1, right? There's nothing here, so there's an imaginary 1 there. The B is going to be 2. What's K going to be? Okay, so really, you can put that so 1 is equal to 1 times n to the 0, because n to the 0 equals 1, right? So that's fine. So that means that our k is going to be 0. So if you ever have a constant here, your k is going to be 0, okay? And now we plug it in. So 1 is what to 2 to the 0? Well, it's equal to it, right? So the 0th power, if anything, is going to be 1, right? So those are going to be equal. So we get that T of n is going to be in big theta of n to the 0th log n. N to the 0th, again, is just 1. So we're going to get this as in log n, which is exactly what we got before, but this takes less time. So if you ever have it in this form here, use the master theorem. Okay, so just to summarize, again, told you this was going to be a quick video because you should be programming right now. Like, get on it. So pro is it's fast. The con is that you don't get the exact count of operations like you do in the foolproof. You just kind of get, the idea of what class it's in, which is good enough because that's really ultimately what people are interested in your algorithm. So let me know if you have any questions. Again, get started on your programming. Yay, programming. And let me know if you have any questions on that. All right, thanks guys.